11 o'clock, first Sunday of the month, which means we are at Prithvi Theatre. Welcome to Chai and Why. In case anybody is coming in for the first time, I see a few new faces. Chai and Why happens on the first Sunday at Prithvi Theatre, third Sunday at Ruparel College, and if a month has a fifth Sunday, we are live from a lab in TIFR. It's something where we take science out in a public domain and just interact with public and see what happens. So before we get to today's program, let me just tell you about the upcoming Chai and Why sessions. The mid-July session at Ruparel College is going to be about biology. It's about morphogenesis, which means, I think, how stuff reaches various things when the organism is growing. So that's going to be biology-based. A month from now over here, the first Sunday of August, remember the end of July, we're going to be having the Olympic Games in Paris. So we will have a Chai and Why on the science of something in the Olympics, probably running or something else. We'll be looking at the Olympic Games. And in mid-August, again, it's going to be protein chemistry or something related to it. But we'll let you know about all of those. But before that itself, so of course, today is 7th. So 7 plus 14 will be 21st. But on the 20th Saturday, 20th of July is International Moon Landing Day. And there is a public lecture in TIFR at 4 o'clock, followed by a interesting cultural program as well, connected to the moon. So that's happening on July 20th at the TIFR Auditorium in Colaba, International Moon Landing Day. Now, with that, it's time to introduce today's session. And it's a pleasure to introduce Amol. Amol Dighe is a professor in TIFR who's somehow given many Chai and Whys even here before. He is a theoretical physicist who's interested in all kinds of anything that's interesting. Amol has various interests beyond physics as well. And today he plans to take the role of Gabbar from Sholay. Okay. I don't know what he's going to do, but we'll figure this out. So the first question, I think, what Sholay is. Okay, maybe we should ask it the other way around. How many of you have not watched Sholay? Have you watched the first half of it? How many of you have not watched the first half of Sholay or the first 10 minutes? Okay, so you see, Amol, there are people who have not. We were discussing on the way that the current generation probably has not watched Sholay.
We'll manage.
We'll manage. Okay, so online audience, please remember that the only way you can ask us questions and comments is on chat. So please let us have your comments, questions on the chat. We will monitor the chat and if necessary, interrupt Amol to ask. If not, we will take them at the end. Of course, you don't get chai if you're online. So on that note, Amol, I think over to you.
Okay. So am I sharing the correct thing on Zoom?
No, wait. Now you have to share screen on Zoom.
Yes. So let us do that first.
Yeah. First, you share screen on Zoom. Just go to the YouTube Chai and Why channel.
Is the correct thing getting shared?
You get it live. You get the live.
It's okay?
Yeah.
Okay.
Wait. I didn't get presenter mode off. This is what we are seeing on YouTube.
It's not.
Yeah.
Okay.
Okay. Now
is that right?
Yep.
Okay. Should I start? Okay. Hi. So welcome everybody. So as we just saw, I see there are people in the audience who perhaps have not seen Sholay, and in particular, you have not seen the scene which has something like this.
Can you get rid of this?
Let me get rid of this. Let me see how to get rid of this. I guess minimize this.
Push it off somebody. Just move it down. Move it down. No, no, no.
Somebody.
And hide floating meeting controller.
This goes here.
I just hide floating meeting controller. That will go.
Okay.
Yeah,
This works?
Yeah.
Okay. So what we did some time back is ask for some volunteers who perhaps had seen this, so that those who have not seen Sholay will understand the background of this. Okay. So let me invite, Rishikesh, you can be here. These guys don't know what's going to happen, most of them. You can come. Aniket, come. You can stand here. Aniket here, next to me. Here, face the audience.
Okay.
Here, face the audience. Arnab, you want to be the first one? Here.
I don't have a choice.
Yeah. You are here. Okay. So to give the background, which I guess 50% people don't need, but let me just give it anyway. Gabbar is, of course, a dacoit, and he sends his henchmen to village to bring stuff, rice and so on and so forth. And once the village in which Jai and Viru have come, they refuse to give, and they defeat the three men of Gabbar, and they come back. Okay, and Gabbar is, of course, very unhappy. This is going to be a play on what's happening, so don't expect great acting. Okay, so as we said, out of this, I don't know, 80% of these people don't know what's going to happen. So, okay, so let's start with so Kalia. How many men were there?
दो थे सरदार, दो.
We are going to perform in English, just so
Okay.
that. And also, we don't want comparison with Amjad Khan, no? So it's just good to do it in English. Okay, I'm going to go in and out of the role very, very fast. Okay, 2 men, and you 3, still you came back empty-handed. What had you thought? Sardar will become Khush? He'll give you a pat on the back? Samba, how much bounty has government given on my head?
50,000, Sardar.
Pure 50,000. Do you know the meaning of this? It means that in village 50 miles away, when a child cries, his mom tells him, child, don't cry. Otherwise, Gabbar Singh will come. But you 3, you have ruined my name completely. This must be punished. This must be punished. Samba. How many bullets does this gun have?
6, Sardar.
6 bullets and 3 men. Very unfair. Very unfair. Yes? So I shoot 3 in the air, no? Kitch count. Okay. Then, and this is very important, I roll the revolver. Now this gun has 3 bullets and 3 empty spaces. Where the bullets are, where the empty spaces are, I have no idea. I have no idea. This revolver has 3 lives and 3 deaths. Let's see who gets what. Attack. ये तो बच गया. Attack. ये भी बच गया. अब तेरा क्या होगा कालिया?
सरदार मैंने आपका नमक खाया है सरदार.
अब गोली खा. Attack. ये भी बच गया. तीनों बच गए. Okay, we'll stop here. I don't want to. So, yeah, so let's stop this and now we'll come back. Okay, So everybody who has not seen the scene, has understood this, because this is going to be background for what we are doing. What I find actually amazing is when this scene you can see in Sholay, it actually explains everything that is needed to do the kind of mathematics that we are going to study now. Okay, and I'll also show you how. Okay, so firstly, of course, there are these three people. Do you know their names? But is not here. Okay. So of course, okay, I'm just trying to go ahead with this. Okay, something is stuck, so I perhaps need some help. Maybe I have to click it once. Let me just click once and see. Yeah. No, it's worked. It worked. It worked. Okay. So Kalia is the famous person. Ah, okay. So let me do this. It is screen share. Okay, let me stop it. Firstly, start sharing again. This one, share. You see it correctly? Oops. Okay. High floating controls. Okay. So Kalia, of course, became very famous. He also got a dialogue to say. Others just had to keep quiet. So these are the most rated people in this. So we'll give them some names so we can talk about them. Okay. So mathematicians like to talk about A, B, and C, right? So we'll give the names as. Oops. I need to click once more, but it will come. Yeah. We'll call them Alia and Balia. So Alia, Balia, Kalia sounds like A, B, and C. Okay. Any other coincidence with any name is completely okay. So now let us try to go back and see exactly what happened. Okay. So a revolver looks something like this. This is what we call as abstraction of a revolver. Now, when mathematicians try to solve problems, they throw away all the unnecessary part and only keep that part which is needed to solve this. Right? Physicists also often do that. You might have heard of physicists solving problems using what's called a spherical cow. A physicist, when asked to determine how much milk a cow will give, the physicist says, okay, let's assume the cow is spherical with this size and so on and so on. That's what abstraction. So this is abstraction of a revolver. So, okay, we don't promote violence. So only thing we are going to look at is where the bullets are. Okay? So this is how a revolver functions. It has 6 compartments, this one. Okay, and the bullets are in these 6 compartments. Once you shoot a bullet, the revolver rotates. Okay, so if the revolver looked like this, okay, after I shoot it once, it rotates like this. This chamber comes on top. Okay, and then if the bullet is here, the bullet it will be shot. If it's not, it will not be shot. Okay, so this is how a revolver works. Now, what has Gabbar told you? Gabbar has told you that he had shot 3 consecutive bullets in the air. Okay, so this is important information because this tells you that 3 consecutive chambers have bullets and 3 consecutive chambers are empty. Okay, so that's very cleanly stated. Gun was full initially because that's why Gabbar asked how many bullets. Samba said 6. So we know that the gun was full. We know that it's actually quite amazing how the director has given us all this information very clearly. Then Gabbar rotates this chamber. Okay, so and then he again makes this statement. I have rotated it, but now which are the empty chambers and which are the bullets? I have no clue. Okay, so this tells you that he has revolved it randomly. Okay, so we have one more piece of information that things have been done randomly, which means that all the positions of this are equally probable. Okay, or equally likely. So there are 6 possible situations of how these things are arranged. Okay, So let me just show you one by one. So the top chamber is the first chamber. So if this is the position, then 1, 2, and 3 are the shots that already will get fired. And so we know that that's actually what happened in the movie. Okay. However, it's possible that the situation was not this, but it was something like this. So now you see, in this case, the first guy, the Alia, would be safe, Balia would be safe, but Kalia, unfortunately, would die. Okay. So similarly, third situation, fourth, fifth, and sixth. Okay. So everybody agrees that there are only 6 situations that can happen. Okay. And now with these situations, we will see what are the probable things that are going to happen in this. Okay. So this, of course, will go away from the screen, but I have got this. Is this visible right now? Huh? So with this, the first thing that we'll do is we'll make a table of these 6 cases. Okay. Where just note down who survives and who dies if things happen. Okay. So I have the table made here, but let's just check the table whether this makes sense or not. Okay. So C1 is this. And now you see that Alia is safe, Balia is safe, and Kalia is safe. Okay. So you can see safe, safe, safe. Okay. Second scenario was this. So now you see that Alia is safe, Balia is safe, Kalia is dead. Third is this. So Alia is safe, Balia is dead, Kalia is dead. Okay. Similarly, C4, C5, C6. Okay. So there are only 6 possible scenarios. So calculating probability is very easy, right? What's probability? It means number of scenarios in which you get the right outcome divided by total number of outcomes. Okay. So now let's ask this question. Before anything happens, what are the probabilities that these 3 people will survive one by one? So for example, for Alia, what will we say? The 6 cases. Okay, Alia is safe in 3 cases. So Alia's probability of survival is 3 upon 6. What about Balia? The different positions, but again, 3 out of 6 Balia survives. So Balia is 3 upon 6. And Kalia is also 3 upon 6. Okay. So let me just write these 3 numbers here. So 3 upon 6 for all of them. 3 upon 6, 3 upon 6. Okay. Now comes the crucial part. Next thing that happens in the movie is first, Gabbar tries to shoot Alia, but Alia does not die. Okay. Now this actually gives us more information. What does this tell you? This tells you that Alia was safe, and that means that these 3 situations do not happen. Okay. So that means I have just made those 3 situations sort of invisible, and we only have 3 possible cases. So C1, C2, and C3. Okay. Now we again calculate the probabilities that these 3 people will survive. Okay. And clearly those have changed. Okay. So depending on when we stop the movie, the probabilities become different. Okay. In the first case, when we stopped the movie, we had no experimental input. It was only theoretical, right? So those things are called as a priori information. Okay. Now what has happened? We have had experimental data. Alia did not die, and that's an important piece of information. And we will see how it actually can make a difference. So now what happens? What is the probability of survival for Alia now? 100%. Alia survived, so of course that cannot change. So this now has become 1 after the first experiment. So good for Alia. Okay. What about Balia now? Okay. So survival probability is 2 by 3, which is, let me just write 4 by 6 so that we can compare easily with this. Okay. And for Kalia, what is the probability of survival? 2 by 6. Okay. So suddenly Actually, nothing happened, right? In the world, nothing changed. As far as Kalia or Balia thing, nothing has happened. The bullets are exactly where they are. They have not changed. But the probability that something will happen has now changed. So how has it changed? Alia, of course, is now safe. For Balia, suddenly the probability of survival has gone up from 3/6 to 4/6. And the probability of survival for Kalia has gone down from 3/6 to 2/6. Okay. So this is the question. What should Kalia do? These places. Okay. So let's try to see what happens when Kalia switches places. So come back, all of you again. Huh? Stop share. Okay. See, last time we'll do it, so it's not, we won't get interrupted so often, but I just thought this will be fun. Oh, gun mere paas hai. Okay, so we'll start with. Okay, so such acts must get punished. Okay, Samba. Samba answers questions before even I asked him. Okay, I'm going to go fast now. 6 bullets, 3 people, completely unfair. Okay, now this gun has 3 lives and 3 deaths. Let's see who gets what. Okay, the scene continues, except now Kalia is a mathematician. Okay, so he calculates things very fast. Anyway, let's see what happens to these guys. बच गया साल.
सरदार मैंने आपका नमक खाया है सरदार.
Do you realize what happened? Okay, so once Alia survived, Kalia figured out that his probability of survival becomes more if he's the second guy to be shot. So Kalia comes and says, shoot me first, and gets his probability of survival to go up. Okay, thanks. Yeah, we'll go to serious business. So let me again share screen. I guess this one. Share.
Yeah, I don't think that will work. You have to go to, you're not on full screen here. This is what you're getting over here. Full screen. Go full screen. No. I think just take the tabs. Just stop share and share it. Yeah. Okay, now you're okay. Now you're okay. Now it's okay.
Yeah. Okay.
Okay, except get rid of your floating meeting controls and all that.
Okay. Okay. So this is what we saw is once Kalia knows that Alia is safe, his chances improve once he jumps first. Okay. So let's just dwell a bit on this. What would happen if Alia happened to die when the Gabbar beat him first? So now what happens? Now the top 3 possibilities are not there, whereas you will get the bottom 3 ones. Okay. So Alia is always dead. Okay. So probability of survival for Alia becomes 0 out of 3. For Balia, it's 1 out of 3. And for Kalia, it is 2 out of 3. Right? So in this case, it is better for Kalia to stay where he was and just hope that his probability will survive. Okay. So in this case, Kalia simply has to survive. Okay. So that's how you calculate probability of your survival. Okay. So when we calculate things like this in detail in mathematics and statistics, we make some kind of charts, and the charts actually help us in calculating. So let's get familiar with the kind of charts that we are going to do. So these numbers that you see tell you probabilities of something happening. Yes, let's see what happens. So first, Gabbar shoots 3 bullets in the air, and that always happens. Okay, so the probability is 1. After that, Gabbar hits the first shot. Okay. Now Alia will be safe with a probability of 3/6. and Alia will be dead with a probability of 3 upon 6. Okay. Now, let's say Alia was safe. Then, as we saw when the Gabbar hit the second shot, if Alia is safe, the probability of Balia being safe was 2/3 and the Balia dying was 1/3. Okay. Then come the Kalia's turn, and then again, once Balia is also safe, probability of Kalia being safe was half and Kalia being dead was half. Okay. When Alia is safe and Balia is dead, let's just see this. Okay. So Alia is safe and Balia is dead would be something like this, right? So Alia first, Alia is dead, then Balia, sorry, Alia is safe, Balia is dead. So now Kalia has to die, right? He cannot survive in such situation. Huh? So with Alia safe and Balia dead, probability of Kalia surviving is 0. Okay. Whereas if Balia is dead, then probability of Kalia dying is just 1. Okay. So similarly, we can make this table, and that's the thing. And finally, when you want to see what is the probability of everybody surviving, if you want Kalia to survive, what you do is you find out all the possible paths by which Kalia is safe, and then you add those probabilities. So what are the possible paths? This way is one path. This is second, which comes here. Third path comes like this. Fourth path comes like this. Okay. So what you do is you calculate the probability of all these paths one by one. And that's quite simple. You just multiply. So here is 3/6 plus multiplied by 2/3 multiplied by 1/2, and you get 1/6. Okay. Fair? Check my calculations because multiplication I'm not very good at. Okay. So then for this, 3 upon 6, 1 upon 3, and 0. So this probability is 0. For here, it is 3 upon 6, 1 by 3, and 1. That is again 1 by 6. And here it's 3/6, 2/3, and half. That is 1/6. Okay. So finally, if you want to know what is the probability that Kalia survives, you will add all these stuff. Okay. So it's 1/6 plus 0 plus 1/6 plus 1/6, which is 3 upon 6. Right? So to start with, we knew that Kalia's probability of survival was going to be 3 upon 6. Okay. But now what happened? Alia survived after first shot. So which means that all of this part has now vanished. Right? This doesn't exist. We are always here. So we start from here bottom. Okay. So now Kalia survives in only 2 ways. One is this path, which is 2/3 times half, which is 1/3. Okay. And here nothing happened. Okay. So 0. Okay. So now probability of survival, once Alia is known to be safe, for Kalia is only 1/3. Okay. This is exactly what we saw earlier. I'm just repeating this because it will be useful for us when we do later fun things. Okay. So before anything happens, the probability of survival was 3 upon 6 for Kalia. After Alia was known to be safe, that became 2 upon 6 or 1 upon 6. Okay. Good. So in this case, of course, Kalia should try to do something different. Okay. Any questions about this? Okay. So no, this is something that you do for fun, but let's do something more and bring in quantum mechanics into this. Okay. So what is the major thing in quantum mechanics that we know? Well, one thing that we know are things are not always certain. So for example, when we learn that inside atom, there is some proton and electron goes around that. Most of our textbooks have the same thing, but we know that that is not what happens, right? It's not that his electron keeps on going around and we can see it going around like this. It does not happen. What quantum mechanics tells you is that electron is somewhere around this nucleus, and what the density of points here shows is the probability that electron will be found there. Okay? So if you see it darker, it means that the probability of finding electron is more. If it's lighter, it means probability of finding electron is less. If it's white, it means you will not find electron. Okay. So quantum mechanics tells us that it is possible that things are somehow spread out everywhere, and depending on our experiment, sometimes you find electron to be here, sometimes you find it to be here, sometimes you find it to be here. So position of electron is not certain. Sometimes the language used says that, oh, the wave function of electron spreads itself around everywhere. Okay. So now what we will do is we'll try to imagine a quantum revolver. Okay. Doesn't exist, no? but we are going to have fun with quantum mechanics. Okay. So what would a quantum revolver work like? Normal revolver, which we call as classical revolver, is like this, no? What you see here. Okay. So if there is one bullet, if that bullet is the one that chamber is going to get shot, then the probability of actually somebody getting shot is 1. If one of these 5 compartments is up there, probability of getting shot is 0. Okay. So it's very clear for classical revolver. Okay. Now this is a quantum revolver that we came up with just to have this giant wire. Okay. So in this, what happens is, if you put one bullet in the revolver, that bullet actually occupies all the chambers at the same time. Okay, and you have no clue where it is. So it's like saying that the probability of it being anywhere is 1/6. It is different from saying that I don't know where it is. Probability actually is 1/6. And what that means is, whichever way I orient this chamber, the probability of I shooting is always 1/6. Okay. So if I have one bullet and I try to shoot this revolver, I shoot with a probability of 1/6. Okay. The revolver, how it works is clear. Yeah.
But I think that the thing is that in both cases the probability is 1/6, for bullet in both cases. It's the same probability that once there is the same probability that there is a 1/6 chance that the bullet will come out. Both cases. So I haven't understood the difference between the.
Yes, exactly. Maybe 10 more minutes and come to the difference. Huh? Okay. So what happens if, so this is, of course, this is a statutory warning. Like this is, no such revolver actually exists. Huh? This is just abstraction. Okay. So if there's one bullet, the probability of somebody getting shot is 1/6, whichever way the orientation. Okay. Yeah.
It was a bit different previously. I think what classical revolver would be that on the top chamber, we know the top chamber is the one which that bullet is shot. If you know the bullet is the top chamber, it's probably 1. But here in this right side, we don't know which chamber the bullet will get.
Yeah.
And the chamber moves forward, there is no bullet. But the probability of the bullet actually being in that chamber once the chamber moves, it is still there. Probability will remain 1/6, even if you have shot one.
No, so good question. I think I should explain this properly. Yeah. So in quantum mechanics, what happens? Yeah. So the question is actually to explain exactly what this is, and I will explain that, so that might make it clear. Okay. So in quantum mechanics, what happens is, when you say a wave function is spread over these 6, okay, it means that the probability of getting any of this in the finding bullet in any of these is 1/6. But when you actually see a bullet, which is like saying in quantum mechanics, make an observation, you actually shoot something, then either the bullet is there or not there. Okay, so either the bullet will be shot or it will not be shot. If it is shot, that bullet will go away and all the chambers will become empty. If the bullet is not shot, the one bullet will stay here, again equally distributed, probability will stay as 1/6. So this is the difference. It is not that this 1/6 gets shot and others 1/6 stay. No. When the bullet is shot, it means that the bullet is shot and all the chambers become. Yeah. Okay. So this is what happens for one bullet. So probability of the bullet being in these chambers is 1/6 each. Suppose the gun has 2 bullets, then the probability is 2/6 each. But what's important is equal. See, earlier we had 3 empty chambers and 3 filled chambers. Okay, now that's not the case. Whatever happens, all the chambers get equal distribution of bullets. Okay, so 3 bullets, again, probability becomes 3/6 each. 4 bullets, it become 4/6 each. 5 becomes 5/6, and if you have 6 bullets, then of course all compartments will have bullets. So wherever you get shot, something will get shot. Okay. So now we are assuming that this is what happens. This is our bullet. This is our scenario. Okay, Gabbar has already shot 3 bullets in the air. Okay, so they are gone. So we are in a situation that is something like this to start with. Okay, so there are 3 bullets. There are 6 chambers, but the bullets are distributed equally in all chambers. Okay, so the probability of you shooting from the chamber is 3/6 to start with. Okay, okay. So now this is the situation. So now when Alia is getting shot, the probability of Alia surviving or dying is 3/6. Okay, because that chamber having a bullet, the probability is 3/6. Okay. Earlier we made a table of the 6 cases and it was very, very easy to count. Now it is very difficult to make such a table, because now when Alia gets shot, all the remaining bullets again redistribute themselves into the 6 compartments. Okay. So this is quantum mechanics, and here is where we have to go slowly, step by step. Yeah. No, all chambers. With all chambers. So it has 5 bullets, they get distributed into all chambers. This is our game. These are our rules. Huh? Yeah. Yeah.
So what you're saying is that, for example, the gun is stuck same bullet. You keep firing it. At some point in time, you'll probably actually get a bullet.
Yes, with some probability, yes. Yeah.
We fire the one bullet that we like, the slot is empty. We know that we are firing and the slot is blank. Now, will the probability of other slots will change? Will it change? Or
No.
It will be
Yeah. No, see, once a shot is fired, then the bullets redistribute themselves equally among all the slots. Right?
In the end, there has to be one bullet. Like if there is one bullet in our volume, then it's for sure that it will get fired in one rotation.
No, if you have got one bullet, then the bullet is distributed in all the 6 slots equally. So when you fire from that gun, the probability of somebody getting shot is 1/6, whichever compartment is there.
I have and I make 6 shots. It is possible that I might not shoot at all the 6 shots.
Yes, yes. So after every shot, the bullets redistribute themselves. So this is the nice part about this. Yes.
There are 5 bullets left, but in which
They came in.
chambers we don't know.
Exactly. That is the difference between classical and quantum.
4 chambers, but which 4 we don't know.
Do not know, right?
So that probability.
Correct. So here you are sure that there's one bullet. If you take 6 shots, as is rightly said, that bullet will be shot. In quantum thing, it's not sure that it will be shot. But everything it gets redistributed, and then you have to keep on hoping that. Yes. Quantum mechanics is actually the game of probabilities. Quantum mechanics works only with probabilities. It's just that we have to keep our intuition slightly aside and think carefully, even rules of quantum mechanics. See, the human being did not evolve with quantum mechanics. No, I mean, we evolved from other animals, and we were not really concerned with quantum mechanics. So our brains are not tuned to think intuitively about quantum mechanics. So it's a very non-intuitive thing. But we know that there are fixed rules by which quantum mechanics works. And if you obey the rules, we get correct answers. So you will see that we will actually calculate the probabilities, just like we did earlier. Even though it seems that the things are very complicated, calculating them is actually very easy. And our technique actually will work. And we'll be able to answer the same questions about whether Kalia should jump or not jump. So let us do that. Okay. So this is what happened with Kalia, of course. So it was very simple for Ali. Now, let's look at Balia. So there are two possibilities. Either Alia was safe or Alia was dead. When Alia was safe, the probability of that happening was 3 upon 6, we did before. And after that, this bullet still has this gun has 3 bullets because nothing has been shot. Okay. So probability of Balia being safe after that is 3 upon 6. Okay. So suppose Alia had died. Then what happens? Probability of Alia dying was 3 upon 6. But now, because Alia is dead, it means that a bullet was shot. So now there are only 2 bullets. So now the probability of Balia being safe becomes 4 upon 6. Okay, right? So if a gun is shot, the probability of you surviving increases because there are less number of bullets in the sky. Right? It didn't always happen earlier. So earlier, no, for Kalia, it actually went up. So okay. Okay. So probability of you being safe. Okay. So if you see how many number of bullets have been shot, you subtract that from 6. That's going to tell you number of empty compartments. Number of well, they're not exactly empty, but this will give you the probability of survival. If there is 1 bullet, probability of survival is 5 upon 6. If there are 2 bullets, probability of survival is 4 upon 6. If there are 5 bullets, probability of survival becomes 1 upon 6. Okay. So all of these things have to be calculated, but they can be done. Okay, you need some patience. We are not going to spend the whole of today doing that, but I will show you. Okay. When you go to Kalia now Kalia's thing is slightly more complicated. So in this case, he has to be really, really fast. Because now there are 4 different cases in which you can get different outcomes. Suppose both Alia and Balia were safe. Then what happens? This gun still has 3 bullets. Right? Suppose Alia dies, Balia is safe. Then this gun will have 2 bullets because 1 bullet has been fired. Okay. Alia was safe, but Balia was dead. It will still have 2 bullets. And both are dead, it will have only 1 bullet. Okay. So depending on that, we can actually calculate probability of Kalia being safe in all these 4 cases. Right? And now we know how to do that. It's very simple. This has 3 bullets. So probability of him surviving is 3 upon 6. Because this has 2 bullets. So his survival probability of 4 upon 6. Okay. This has 2 bullets. So again 4 upon 6. And this has 1 bullet. So his survival probability of 5 upon 6. Okay. So all of these things can be very easily calculated. Even though quantum mechanics is complicated, probability is not difficult. Okay. And then we can make the same kind of table. Okay. Now trust me that I did this correctly. If you find mistakes, you tell me. Okay, but we will not go through this. Okay. So what we'll do now is using this table, we will calculate the probability of Kalia being safe. That is our aim. So you can again go through different routes. One route, the same routes, right? Route number 1, route number 2, route number 3, route number 4. Okay. So if I multiply this, 3 upon 6 times 3 upon 6 times 3 upon 6, 27 upon 216. Okay. Similarly, if you go from here, here, and here, is 3, 3, and 4. So that is 36 upon 216. This is 48, and this is 30 upon 216. Okay. So what is the probability now of Kalia surviving? Somebody can sum these things up. I did not write the sum there. But 141. Okay, let me trust you. So upon so this is the probability of Kalia surviving. So when the game starts, Kalia has this probability of survival. Okay. Now what happens? First bullet is shot and Alia survives. Okay. So Alia survives. This part goes away. Only this part stays. So you have to go only below this because this is also known. So Balia safe, Kalia safe is 9 upon 36. And here, I think Balia dead, Kalia safe is 12 upon 36. Right? So add the two. 21 upon 36. So 21 by 36. So let us start to simplify things.
47.
47, 72. 72, and this becomes 42 by 72. So what has happened? After Kalia was saved, the probability of him surviving actually went down. Okay? So the probability changed as once he knew that Kalia was saved. Okay, so this was just to show that what should Kalia do? So his probability of survival actually goes down. Okay, so just stay there. Okay, so remember, so first case, if the revolver was nice classical revolver, Kalia should jump and say, "Maine aapka namak khaya hai, sir." Right? The second case, if it was quantum, should just stay put and say, "Okay, let me be the third one and see whether it is." Okay, so it's a question of life and death for Kalia to do these probability calculations to know whether the revolver is classical or quantum. Yeah.
The second, after Alia is saved, probability of Malia being dead is half, and it is more than half. And this probability is more than half.
Kalia is half, is it?
Malia
Balia is half. Okay, let me check again. So we'll see. Anyway, the probability change. Okay,
Kalia should stay.
so you should stay where it is. Yeah, that's it. Okay. So now, if it's the question of life and death for me, I should know what kind of revolver Gabbar has. Okay, this is of course our dream world, not the real. Okay, so next question. We're just going randomly, by the way. This has no connection with each other. So question is, how do we identify if the revolver is classical or quantum? Yes, one second. I'll come. Yeah, go ahead. Yeah, but we already know that the 3 bullets have been shot. So you have seen those 3 shots. Yes. If it did not shoot, then yes. But now that the 3 bullets are shot. So what is the situation? The situation is that Gabbar had shot 3 bullets in the air. So this is given. So that is not to be changed. So now in the future 3 bullets, can we say something? Let me your guess. Yeah. Yeah. Just one second. I'll come to it. Yeah.
So, is this in a place where quantum revolver exists, or is it in a place where you can make the quantum revolver, if the classical revolver will work as a quantum revolver, it spins the dial of the time?
No, so we are now living in a world, see imagination, okay? We are living in a world where revolvers are either classical, our standard rules, or they are quantum, which obey these rules. So there are 2 kinds of revolvers exist. And now your job is to find out which of these revolvers is there by observing those things. Okay. Yeah, you had some. Okay. Yeah. But you know, because it is possible. See, it's not. It's possible that all those 3 bullets get shot, right? Right. Okay. Nice, nice. So we'll actually come. We will come to this part. Yeah. You had a comment here. Same comment. You had a comment here.
Then if 2 shots also get fired simultaneously, then what you will explain right now, that there is no possibility of identifying whether it is a quantum because the bullets can go anywhere.
Yeah.
So whether the bullets actually get shot together or don't get shot together, the probability is very big.
Yeah.
So it's very difficult to figure out.
Yes. So at one time, only 1 shot can get fired. Yeah. Mm-hmm.
If that first shot goes, can be a classical revolver or a quantum. If
Right.
the first shot after the third shot doesn't go, then we invariably know that it's a quantum.
Very nice. Yeah. So that is one way for you to know, right? If even the fourth shot was empty, actually wait. So let me be correct, because you know after those 3 shots, no, after those 3 shots were shot in the air, the Gabbar actually moves the revolver. So this will not work. So it's possible that you landed up at the wrong place. This is the fun things to think about. So there are cases that we will discuss. Go ahead. Yeah, first one, yeah. Here. Mhm. After Alia is safe, yeah. Yeah. No, so calculations are different. So you have to compare this part I did not do. You have to compare this with this. So Kalia says survival of my survival versus Balia's survival. If this is there, then you join. Okay. So I did not show you Balia's survival probability.
Other groups are in sequential.
Yes.
String together.
Yeah. So in classical, they are sequential. In quantum, they are distributed everywhere. So this is the difference. The reason that we are doing all this is, so this is the thing where we have to tune our intuition all the time. Every time bullet gets shot, the bullets redistribute. We have to redistribute our thinking too.
Multiple cases.
Basically, all about using your imagination till the last second, because anything can happen, anything can change.
Yes.
But the probability of what will happen according to you, according to your imagination, and you
Yes.
keep varying the probability.
Just to correct you, it's a bit. It's not according to my imagination. There are rules that you follow. There are rules that you follow. It works. Yeah. Yeah, okay, yeah, agreed. Yes, indeed, yeah, that should be one way of finding. Yeah. Good. Yeah. Okay. Yeah.
Every time we fire, we should also after that rotate the chamber. Then it behaves just like a quantum. And classical behaves like quantum with the rotation, random rotation happens after every shot. We get the same diagram, the same thing.
So wonderful. Yes. So in this particular case, yes. So, but we'll make a comment on this afterwards. But yes. So if, for example, Gabbar was shooting once and then rotating arbitrarily, then you get something which is very, very similar.
When he shoots in the air and then he doesn't rotate the barrel, then for sure we can tell that it's a classical
Correct.
bullet. If in the fourth shot we are getting the bullet.
Yeah.
But
this question that after fourth bullet, if the barrier is there, it means it is a classical or so if you jump it.
You cannot say for sure.
You cannot say for sure. Refalia.
See, first bullet, fourth bullet, there are 3 bullets. So fourth bullet is definitely going to
No. So after 3, if you did not rotate.
No, you rotate from bullet.
Okay.
After 4 bullets, it's certain that it is a classical revolver.
No. So
Because 4 bullets,
in the fourth bullet, Alia is dead. Then maybe you are somewhere here. Okay. It's okay. This is still a possible sequence. Okay? Yeah. No, but this is also a possible sequence where Alia will be dead, but both Balia and Kalia will still survive. Yeah. Yeah. Right.
Either they will come or they will not come. But once the Alia is there, it is definitely that the
No. So let's say after rotation, this compartment comes the first. So Alia will be dead, but Balia and Kalia will still survive. So it is possible for this situation to happen. There are some situations that people mentioned somewhere on this side which do not happen. So there are certain things which we will come to. Only the classical. Correct.
Okay,
Right.
for a few minutes and let him proceed. Yeah.
Okay. So I'll come to most of your questions are expected and no, perhaps we'll get answered very, very soon. Huh? So question that we are asking is how to identify classical versus quantum revolver. Okay. So if we just see, so if we just see these three blanks which we just saw, it is impossible to say, right? Because three blanks can happen with classical, three blanks can happen also with quantum, right? So with this is impossible to see. So as somebody out there said, the ideal way of doing this would be to do the experiment many times. So in fact, this is true in all of quantum mechanics. Okay, it is almost never possible to make one observation and say whether something is quantum. You actually have to do observations many times and then you figure out if what you measure actually works or not. Okay, because in quantum mechanics, it's possible that your system is the same, you follow the same protocol for making measurements, but answers are very different in experiment 1, number 2, number 3. Like we saw, for example, that if you have an atom and you try to measure where the electron is, electron can be anywhere, can be here, 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 or here. It happens with some probability. Okay? So quantum mechanics is strange in some sense. Okay? So sun, for example, produces particles called neutrinos. And if you try to measure the mass of these particles, you get 3 different answers. Okay? And sometimes you get answer 1, like sometimes you get answer as 5, sometimes 15, and sometimes 73. Okay, I just put random numbers. Okay, so in nature, it actually happens that the same experiment can give different answers, especially if some quantum phenomenon is involved. Okay? So just like here, now, if you reenact the movie 100 times with a quantum revolver, you will get different answers, right? Okay. Okay. So what you need is what we call as a quantum movie. Okay. Or another way that people think of is an ensemble of movies, which means you take lots of movies, except with every movie something else happens. Huh? So and then you have a person like Samba who's sitting there. He's an observer. What does an observer do? Observer watches the movie again and again and again. I know there are people who have watched Sholay, I don't know, 100 times, right? Okay. So Samba can sit there, watch this movie 100 times. So it's quantum movie, so the outcome changes every time. And you figure out whether it matches the predictions or not. Okay, so that is one way. But then we wonder, I'll come to it. Can Samba get lucky? Is it possible that Samba doesn't have to watch this movie 100 times? He just sees the 3 bullets and figures out if it is possible to, if the revolver is quantum or is classical. Okay, maybe I'll take comments now. Yeah, yes, yeah. Yeah.
The first time, because or basically if it's yes, no, yes, or no, yes, no. Basically, if it's anything like that, we can tell it.
Very good. Yeah. You had some? I'll come to you. Same as. There's some comment here.
Same thing. When I was at this classical accounting, if Alia lives, Kalia lives, but Kalia dies. Or if Alia dies, Kalia lives, Kalia dies.
Yes, yeah. Yes, sir.
Classical, you can say, because even after putting one bullet, 2 still will stay together. Whereas in quantum, we know for sure that it may not remain together.
Right. Yeah. So that's correct. In fact, you guys have boiled down on the right answer. I'll get.
Single trial, you can tell if it's quantum or not. We will never tell if it's classical, because the same case that happens classical and also happens in quantum. While the only case where in quantum, there's a case where, as he said, we die, live, die. That cannot happen in classical. So in a single trial, Samba can only get lucky to identify as a quantum revolver.
Wonderful. Yeah, nice.
Can you ever force them to put in the classical method? Force them can always act as a classical.
Yeah, good. Yeah.
It's a very general. So I was a big fan of design theory. So my information comes from there. So the idea is that quantum this concept, you are actually concentrating on one probable solution that you think is the most probable, and then you actually work towards finding the probabilities and the possibilities of that one solution being the reality of that particular entire concept. So whether it is true or not, you actually figure it out through a series of experiments and a series of probabilities that you would then try and figure out.
Correct. Exactly.
So in this situation also, whether it is the truth or whether it is not, you will actually have to go through a series.
Exactly. Yeah. Yeah. No, you're absolutely correct. So this is the way that you test whether quantum theory is correct or not. It has some predictions of different probabilities. You do the same experiment 10,000 times, a million times, and see whether that answer is correct. Okay? And check with what probability, what outcome happens. And if that is what you predicted, then your theory is most likely to be correct. That's the way it happens. Sometimes you get lucky. Sometimes. So this is, but I have to see whether the Samba can get lucky. And in fact, no, from the answers I got, the questions on this slide have already been answered by you guys, okay, in the last 2 minutes or so. Okay. So Samba watches next only once. The question is there a sequence of 3 shots that can assure Samba that the revolver is definitely 100% a classical revolver? Okay. And I got this answer from the audience that the answer is no. Because anything that can happen classically can also happen quantum, right? So one experiment is very often doesn't enable you to find out whether it is to sure, say that classical very sure. Okay. Second question is slightly different. Can a sequence of 3 shots tell Samba that revolver is not classical? Okay, and that we said yes, because I think 3 or 4 of you, maybe more, gave me the answer that if alive, dead, alive happens, or dead, alive, dead happens, that is impossible with a classical revolver. So if you see that, it has to be a quantum revolver. Okay, so I don't have to tell you this. Okay, so in fact, if you look at the chart that we had seen earlier, so you remember we said that some of these things cannot happen here, here, and here. Right? If you see this sequence, all 3 are safe. You were in a situation called as C1, which was this orientation. Right? If you go here, here, and here, it was in C2. But then we said this cannot happen, which means Alia safe, Balia dead, Kalia safe cannot happen in a classical scenario. Right? Similarly, Alia dead, Balia safe, Kalia dead cannot happen in the scenario. Other scenarios are listed as C1, C2, C3. So that works. Okay. I just wanted to make one nice point. It also came up because in one of the comments that was made here. Yeah. Disproving classical thing didn't happen doesn't actually mean that quantum theory is true. So for example, somebody, I forget who had this. So maybe it's possible that the revolver is some strange revolver where although after shooting, Gabbar doesn't do anything, but revolver has some hidden mechanism that can just rotate it arbitrarily, randomly. Then what happens? Then anything that we just said will happen on quantum can also happen on classical. Okay. So in physics, actually, if you want to ask this question, that answer is not always easy, right? So in fact, this is dead survives dead or survive dead survive. Okay. It is not possible classically, but observing them so observing them disproves the classical revolver hypothesis. What is the hypothesis of classical revolver with internal mechanism? Which is, let's say the movie director did not tell you what the mechanism was, but there was a mechanism. So when you want to find out if some phenomena has classical or quantum, it is not enough just to show that this cannot happen classically. So you have to think of, are there possibilities where it will not give the classical answer that we think intuitively, okay? But something hidden happens. So those things actually in quantum mechanics are called as hidden variable theories, okay? Saying there are some things that we cannot measure, okay? But there is something that, the bullets are not distributed in all of them, probably 16, 16, 16. They are in some particular compartments. We just don't know where, because there is some genie sitting inside who just puts them in random places, for example. And a lot of work actually goes on, has gone on, in trying to figure out very careful observables, where in spite of this, you are able to figure out if there is, the things are quantum or not. Okay, so I won't go into that, but these experiments are called as Bell's inequalities, okay, which means that these are very carefully clustered experiments where a genie sitting inside who does random things also cannot give you the quantum answer. Okay? So I will not go into this. It needs a completely different Chai and Wai, and perhaps something may have happened because the Nobel Prize a couple of years ago was given on this, to actually for people who observed, Allen Aspect and company, who actually observed that Bayes inequalities do not hold. So it is a big question for which very, very clever experiments have to be designed, not simple ones like we are doing here, to figure this out. And it has been observed that indeed the results of those experiments tell you that the world is quantum and the world is not actually classical. Okay, how am I doing with time?
When do we take a break for chai? It's already 1 hour plus.
Then I will take a break here. After the break, we will talk small things about how to escape Gabbar using quantum mechanics.
Okay, so what we'll do is we will take a few online questions.
Okay.
And then stop the live stream before we go forward. Are there any online questions?
Yeah, but actually, it's not really related to today's topic about standard model of quantum.
You choose whether to take this or not. Well, maybe I don't want to disturb the flow, but it's your choice.
Why is it that everything comes with fees in standard model?
Nobody knows. Simple answer. Simple answers I can give. So nobody knows.
There are some suggestions of. There are some really wide suggestions of using a quantum revolver and a double slit and using Kalia and the minimum.
Sometimes people on YouTube. So I just wanted to say something. Sometimes people on YouTube just know what's coming next.
Okay, so I think wait, there's one who just come in. It is assumed that Gabbar spent sufficiently long between two consecutive shots so that the bullets get enough time to redistribute equally in the quantum revolver?
Yes, indeed.
Yes, the answer to that is yes.
That is why he has these dialogues, no? The dialogues give the bullets time to. Okay. No, clip perhaps we are not allowed to.
If we are live. So there's some copyright issues with that. So on that note, we're going to stop the live stream here. And of course, we're not stopping the session with the live audience here. We will go have chai and come back. But online audience, just to remind you that the next Chai and Wai on the 21st at Gabbar College will be before that. July 20th, Moon Landing Day. There are lots of events happening in the afternoon, evening at the IFR. We'll put out the announcement for that. The Chai and Wai on the first Sunday of August is going to be on the Olympics, and after that, there'll be one on protein chemistry. So that's the events coming up next. Thank you for joining us. If you have further questions, please email them to outreach@theifr.ras.in. We will try and take them or convey them to Amol. And audience over here, I hope you've been confused enough. I will help you and come back and we can discuss more probabilities over here. Okay, so thank you.